Welcome. In this video we are examining a dataset that shows how many words 30 different Border Collies learnt after 1, 2, 3, 4 and 5 hours of training. As we can see, this is going to be a numerical dataset, hours spent learning, plotted against another numerical dataset, number of words learnt. Therefore we will use a scatter plot to assess any trends in our data. However, before we start we will quickly recap how to conduct univariate analysis on our datasets. You will notice that under the dataset, I am typing the title, and in the adjacent right-hand cell, I am typing equals, followed by the exact calculation needed to conduct the analysis. Once the data has been selected and the brackets closed, I will press enter. This is then repeated for various different statistical values that help us understand the central tendency and accuracy of our data, including mean, median, mode, range, standard deviation and standard error. Watch the video carefully to help understand the process of conducting calculations. Some calculations, such as range and standard error, cannot be calculated directly by Excel, hence the rows labeled minimum, maximum and number of samples. The minimum and maximum rows are used to calculate the range by taking the maximum value of the dataset and then subtracting the minimum value. Whereas, the number of samples row is used to help calculate the standard error, which is calculated by dividing the standard deviation by the square root of the number of samples. As was mentioned earlier, we can tell a lot from these different values. For example, the mean tells us a quick summary of the central value of a dataset, as does the median. However, the median can be useful for datasets with extreme outliers as it reduces their impact. The range is a very simple way to show how spread out the values are in a dataset, which then allows us to assess the reliability of the experiment. While the range is a simple and quick measure, it should not be the sole measure of dispersion used for in-depth data analysis. Instead, standard deviation should be used, as it takes into account all values in the dataset, and therefore, gives a more holistic view of the reliability of the data. Finally, standard error indicates how accurate the sample mean is. The more samples you take in an experiment, the smaller your standard error becomes, and consequently, the more accurate your mean value is, that is, the closer it becomes to the true value. This all assumes, of course, that you conducted a valid experiment, in which you controlled all external variables. Hopefully, the ease in which all these calculations were conducted has already made the value of using Excel apparent to you. But if not, hopefully the next step, in which we can quickly replicate these calculations for other datasets, will. Simply highlight all the calculations, hover your cursor over the bottom right-hand corner until the black cross appears, and then select and drag across as shown. This will replicate all the calculations just done, in a fraction of a second. By simply adding a suitable title to the top of all these calculations, such as Table of Descriptive Statistics, you now have a table that would be worthy of including in your final report. Another way to quickly assess the central tendency of your data is to produce a series of box and whisker plots. These plots can be easily produced by highlighting the data, clicking on Insert in the menu bar, and then selecting histograms and box and whisker as shown. These box and whisker plots quickly show the means of the data sets, as indicated by the X, the median, as indicated by the line through the middle of each box, the maximum and minimum values, illustrated by the ends of the whiskers, and also, perhaps most importantly, they show any outlying data points. A cursory look at these plots show there seems to be an outlier in each data set, and when we look into this, we quickly see it is due to dog 26. Was there a mistake with this dog, or was dog 26 just really special? Only the scientists who conducted the experiment have a real chance of answering that. It would be up to them if they choose to leave it or remove it, but either way it should probably be addressed in their discussion of the results. We are now ready to plot our data on a scatter plot. This can be done by highlighting the independent variable that will go on the x-axis. In this case it is the hours of training, and then pressing Ctrl, and then highlighting the mean results for the dependent variable, words learnt. Once these two rows are highlighted, go to Insert on the menu bar and select XY Scatter. We can then add custom error bars by selecting the green plus sign at the top right of the graph, hovering over the error bar option and clicking the small arrow. You will then be prompted to choose more options. If there is no variation in your x-axis measurements, it is advisable to delete those error bars as shown here. Once you only have error bars in the y-axis direction, you can select Custom and then specify value. From here a small dialog box will appear prompting you to add the error values. Click the up arrow and then select your standard error value from your previously made table. Repeat this for the negative error values and press OK. At this point, we can also add a trend line. Again, this is done by selecting the green cross and choosing Linear and more options. Click the histogram icon at the top of the right-hand dialog box and choose both Display Equation and R². In this dataset we can see the R² value is 0.9955. This value is so close to 1 that it suggests an incredibly strong correlation between the two variables. That is, almost all variation in the words learnt by our dogs can be explained by the time they spent training. Put another way, the rather obvious result is that the more time a Border Collie spends learning words, the more words they will learn. Before we finish up, as always, it is important that a graph is labeled correctly in terms of its title and axes. You can double-click the graph and this will open the flowchart design bar at the top of the screen. On the left-hand side you can select a variety of different quick layouts that will assist you. Be sure to include units on your X and Y axes. You now have 3 very good items that could be included in your data pages. 1. A table of descriptive statistics. 2. Box and whisker plots of your data sets. And 3. Your final graph that show the overall relationship between your variables. Now, give this a go with your own data. Spend time arranging it in a similar way to what was done here, to make it easier for you. Good luck, and don't forget to ask your teacher for assistance if you need it.